Hey, for everyone who have a problem or confusion with a piecewise function, I'm here to help with an example. So the piecewise function is actually made up of the pieces and they put together on different time interval, but they put together on the same graph, but they're actually the parts, the pieces. They can be discontinuous or they can be continuous. Alright, we have an example here. We got minus x minus 4 where the domain is x is less than negative 2 and it's equal to negative 2. And then the second equation x, and then it's negative x plus 4. So what we did do, they put restriction on each of the equation. So we have to follow it and then put it on the graph. Not only the equation, but the restriction as well. So we use the first one, which is negative x negative 4. We know it's mx plus b, so m is equal to negative 1 over 1, which means it will be a down, or we move down one place and we move forward one place, negative 1 over 1. And for b is negative 4, the y-intercept is negative 4. In the graph, we're gonna do is we at negative 4, we start at negative 4 and then we move down 1 and then move 1 to the right, right? So here we got this graph, 1 2 3 4. We go down 1 and then we move 1 right, and then again same process, we made a straight line. But in order to follow the domain, it says it's negative 2. It's only hold when it's negative 2. It's less than negative 2 and equal to negative 2. So x value where it's negative 2, it's here. So we don't use these points. And it's equal sign, that's we use the solid points. But if there is not equal sign, just only an equality there, we use the whole. Here's equal sign, we use the solid line, and it goes up. This is for the first, and for the second one is only x. So we know here we have to follow the restrictions too. It says it's only hold when it's negative, the x value is greater than negative 2, but it is less than 2. There is no equality sign there, so there will be a hole there. So max value is negative 2 and 2, but there is not equality, so there will be a hole there. So we use negative 2, negative 1, 0, 1, and 2, right? And we put in the equation. So what we put x, we got y, because both of them are equal here. So negative 2, negative 2, negative 1, negative 1, 0, 0, 1, 1, 2, 2. And we know at negative 2 and 2, as it's not equal, there will be a hole in between those points. Between these points, the values remain the same, right? Negative 1, negative 1, x value negative 1, x value negative 1, y value negative 1, x value positive 1, y value positive 1. But there's a hole there, so it's for the second one. For the third one, we got minus x plus 4. Here, what we're gonna do, it is greater and equal to negative 2. So its equation is minus x plus 4. It will be in the slope-intercept form, which is right there. So m value is negative 1 over 1. What we're gonna do is start from the slope-intercept form, y-intercept 4. We go up 4 and then down 1 and right 1. And the same way, down 1, down 1, right 1, down 1, right 1, we have a line. But in order to follow the domain, we have should be greater than 2 or equal to 2. There will be a solid line, solid dot at 2, and then it'll gonna proceed till infinity, right? Till infinity. So we got one graph right there, we got second graph right there, and we got third graph, second graph right there, and third graph right there. So we're gonna combine all of them. As combination, we get this picture. And because of it, it's a solid dot here, but it's an open interval here, which is in the second graph we just mentioned. But here is solid line again, solid dot again, and then it goes to infinity. This one connected together, that why is piecewise continuous.